Okay, today's lesson is 12-8, translation of trigonometric graphs. So what we are doing in this lesson is taking what we just did in the previous lesson, taking those graphs that we have shrunk vertically and horizontally, compressed and stretched, and now we're going to be moving them up and down and left and right. Okay, so to start off with, okay, so again, yesterday or the previous lesson, we had A and B. Okay, A represented, of course, our amplitude, and B is what affected our period, 2 pi over the absolute value of B. Well, H and K, a lot of times some books refer to that as C and D, but H and K makes it a little bit easier because that's what you've been doing all year long. Okay, the only difference, so H represents what we know is our horizontal shift, a horizontal translation. On a sine graph or on a trig graph, it's referred to as your phase shift. Okay, and K is still your vertical shift. However, it's also what is known as the midline, and it's going to be, you're going to see that when I start graphing these functions, that is going to be the place I actually start the graphing, and just makes it a little bit easier. Okay, just like, so you're going to hear me saying this again because H is our phase shift, and it goes with what we X or theta, however you wish to think of it. But if it's inside, it affects that X and it's moving left and right. K is on the outside, it's going to be moving up and down. So let's go do some examples. Now, I have the graphs here, y'all, because that was easier. I'm trying to keep these videos kind of short. So hopefully you will get enough information and be able to follow what I'm saying to do it on your own. If you need any help, let me know, please. Okay. To start off with, y equals the sine of theta plus pi. You always start with what is your amplitude, all right? And it's the number in front of your trig function, so it's 1. Then I'm going to look at the number that would be in front of theta, which in this case is 1 again. So my period is 2 pi over 1. So what else do I have is I have pi, and that is going to affect, that's my phase shift. And it's always the opposite of what it looks like in the parentheses, so I know that I'm going left pi units. Now, just like we did when I did every one that I did yesterday, when I know my period, I'm going to go out 4 tick marks, 1, 2, 3, 4, and I'm going to label it what my period is. And then I go halfway, label it, and then I add those two together, and you can see that it's continues. So each red line is pi units, okay? Then what I like to do, if I have a phase shift, then I'm going to go up here and I'm going to say, okay, how many tick marks is pi units? Well, that's 2 tick marks on my graph. So when I actually start graphing it, you'll see when we start how that goes into play. All right, so I've labeled my x-axis, theta. My y-axis, I don't have any kind of different number for my amplitude, so I know it's just going to be up 1, so I don't have to relabel that. Okay, so when you start, you go, okay, I got the sine function. Sine starts at a 0. Okay, so if it starts at a 0, that is normally, nope, wrong one. I want this one. I won't take it. It won't let me get it. Hold on, Pooh Bear, stop. I want that. I want that. There we go. Sorry. Okay, so sine normally starts at 0, but I have to move it to the left 2 tick marks because of my phase shift. So what I'm going to do is highlight 1 period because that's how I always graph it. I start with that 1 period. So my first one is going to be, and actually when I do that, I want to make sure that I'm at I'm at a fat one, so you can see what I'm drawing there. Come back here. Okay, so stop it. So I would normally start at 0. I'm going to go left 2 tick marks. That's going to put me right there. And my period is 4 tick marks. So 1, 2, 3, 4. That's the end of the period. Halfway between. So it starts at a 0, ends at a 0. Halfway between is a 0. Halfway between the first 2, I go up. And halfway between the last 2, I go down. So that is the main thing that I graph. And then I just follow that pattern and connect them to get the graph going. Okay. Last thing we have to do for this problem is identify the domain and range. It's a gimme for sine and cosine because the domain is negative infinity to positive infinity. My range, what's the lowest point? -1. Highest point, +1. So I'm going between -1 and 1. Okay. 24, the next one. Okay, so you might, if you printed these off, y'all apologize, but I realized afterwards that all of these were sine graphs, and so I changed some things before I do the video. So if you have sine on yours, make sure it's cosine, because I wanted to make sure I did one of each. Okay, so to start off with, my amplitude, I've got a 2 in the front, so my amplitude is 2. The number in front of theta is 1, so my period is 2 pi over 2. Okay. I don't have a, well, let's just talk about what this 4. This 4 is not inside the parentheses, it's outside. So that means it is a vertical shift. And when it's outside, it does the same thing. Okay. And that's where I'm always going to start my graphing. Okay. Somewhat. I say that because, of course, I always start by labeling the axes first. So let's go label. We'll start with our period. Period is 2 pi. I'm going out 1, 2, 3, 4, labeling it 2 pi. Halfway is pi. So just like we had before, those are the red ones are all multiples of pi. Okay. Then I am going to actually think about my midline. Okay. So -4 is the vertical shift, and that makes y equals -4 the equation of the midline. And if I didn't emphasize it enough, what this amplitude tells y'all, okay, is whatever my midline is, I'm going to go 2 above it and 2 below it. That's what the amplitude is. Our normal parent function has the midline at 0. So if my amplitude is 2, I'm going to go up 2 and down 2. So everything is just shifted. So when you're graphing it, think of this as your new 0 line. Okay, so that's my midline. I don't have a horizontal shift. I have an amplitude of 2. I'm graphing the cosine. Cosine starts at a max. So if it starts at a max, then at my 0 for my y-axis, or 0 on the x-axis, I'm going to go up to a max, which in this case my amplitude is 2. So that's why I'm going up 2 units from my midline. Okay, and then I go to the end of my period, 1, 2, 3, 4 tick marks, and put another one, the exact same thing. Halfway between my 2 maxes is a min, and halfway between each max and min is a 0. So those are, this right here, these are those points that are giving you just one period. But as always, I want you to fill up the graph. So you just continue the pattern, and I think it will help you understand a lot better. Okay. Domain, gimme, negative infinity to positive infinity. Range, look at your graph. I mean, you got choices. You can go back to your parent function and do some math, or you can just go look at your graph. What's the lowest point? -6. What's the highest point? -2. So I'm going to say -6 and -2. And of course, it's inclusive because we have those points. Okay. Number 30. Oh, look at this. We got a lot of changes in here. Okay. Y equals 1/2 sine, parentheses, theta minus pi over 2, close parentheses, plus 4. So I have to say something about all those numbers, and I'm going to talk about what each one does to the graph. So the 1/2 is in front. It affects my amplitude. The number multiplied in theta is 1. There's not a number, so my period is still 2 pi over 2. Okay. This pi over 2 inside the parentheses is a phase shift, and I go the opposite, so I'm going to the right. And then my 4 is outside, and it is a vertical shift, so I know I'm going up. So I'm going to go, my period is 2 pi. I'm going out, same thing we've done, 1, 2, 3, 4 tick marks, label it 2 pi. Halfway is pi. Add them together to get 3 pi. You got the pattern, all multiples of pi. Okay. Now, before I'm going to figure out what my vertical needs to be, whether it needs to change. But if my amplitude is 1/2, I probably don't. But the point is, on my grid, my midline is now y equals 4. So I go up to 4, and I just draw a dotted line because it's not part of my graph. And that's my midline, and my amplitude is 1/2. So I only have to go up 1/2 and down 1/2 from that. So I don't need to renumber my y-axis at all. Okay, so I've got my midline. I know I have plenty of room on my graph to plot my points. So y'all, my midline was 4 and my amplitude was 3. then that would be so high above the graph I might consider labeling it by 2's. That's just kind of the thinking ahead a little bit that you can do. Okay, so I have labeled everything. I've got the sine graph. Sine graph starts at 0, 0, which is this point right here. That's 0. It's my 0, 0 because my midline is my new little 0. Okay, sine starts at 0. Okay, but I have a phase shift of pi over 2. So really, I need to know how many tick marks is pi over 2. Well, if this first red line right here is pi, then surely y'all know that this right here is halfway between 0 and pi. So that means that right pi over 2 means I go right 1 tick mark. So my 0, 0 point, when I move it to the right 1, means that I'm starting at this point right here. So that's my first one. I go 1, 2, 3, 4 to the end, halfway between my zeros. So I started at a 0, ended at a 0, halfway between a 0, halfway between the first two is up my amplitude of 1/2, and halfway between the last two is down my amplitude of 1/2. So those are the key points that I've graphed, and then I just put the other points and connect them to make it look all pretty. Okay, so again, give me for my domain, positive infinity to negative, or negative infinity to positive infinity. My range, okay, what is the lowest point? What is this point right here? Well, if that's 4, and I went down 1/2, that's 3.5, and this one is 4.5. So half or 0.5, whichever one you want to write. Okay, so you need to be able to give me this information should be very easy for you to get. This is from the graph, okay, but putting it together is kind of what's the hardest part. So I hope you let me know if you have any questions. Okay, so again, as you can see, I changed it. So I took 32 from the homework problems, but I changed it to tangent because I wanted to do a tangent graph. So let's look at what we have here. Y equals 3 plus 5 tangent of 2 times theta minus pi. Okay, again, I start with the amplitude, but it's not really the amplitude, but I wrote the amplitude because I shouldn't have written amplitude. I think I'm going to take that off. That's just my A value. Let's just go with that. Okay, so that's my A value. That's my vertical stretch of the graph. Okay, the 2 affects my period, and the period of my parent tangent function is pi, so it's pi divided by 2. Okay, it is a tangent function, which means I'm going to have asymptotes, and you need to remember where the asymptotes are, and they are always at half your period. So I'm going to show you how we put that together. Okay, so I've identified the 2, I've identified the 5, the pi is inside, so it is a phase shift, and it's to the right because it's the opposite of what it looks like. And that means that 3 is over here, but it really could be written at the end. So that is my vertical shift, and it does this positive, so it's going to go up. Okay. And as I said, especially when you have multiple things in here, y'all, that is where you want to start your graphing. So, and if you can tell, so this is my new midline of y equals 3. Okay. And A tells me that that key point is I'm going to go up 5 and down 5 from that point. So 3 plus 5 is up to 8, and 3 minus 5 is -2. So I want to make sure that those points are on my grid per se, so it makes it easy to graph. Okay, so what am I doing? And remember, the other thing is that I talked about was trying to figure out how many tick marks a phase shift is. But let's start at the beginning here. So when I've got all this information, I have to plot it. I'm still going to go 1, 2, 3, 4, label it my period, and halfway is pi over 4. That is where my first asymptote is, okay? So you would technically put your asymptote here, y'all. So my first asymptote is, I got the wrong color. My first asymptote is here, and my period is 4. So I know that that's where my original asymptotes are. That's without a phase shift, okay? Now, I need to figure out how far is pi. How many tick marks is pi units? Well, if you can look, we have pi over here at the end of the graph, and that's 8 tick marks. So I have a phase shift of 8 tick marks. So I'm going to take this asymptote, and I'm going to move it 8 to the right. Well, 1, 2, 3, 4, 5, 6, 7, 8. It actually landed where a tick mark is. So that means that this phase shift has no, it doesn't really change the problem at all, y'all. You can just do it the way you did normally. So that's why my tick marks are where my asymptotes are where they are. Okay. The next key point that I have is halfway between the two asymptotes is a 0 on my midline. So I have that point right there. And then I'm going halfway to the right, tangent rises. So halfway between the 0 and the asymptote, it goes up to that A value. So up 5 puts me here, and left down 5 puts me there. So I have my asymptotes are 4 units apart, and I'm going to continue that on my graph and then connect it to look like the tangent graph. Okay, so my domain, this is the hard one, kind of, sort of. Okay, but we talked about yesterday. If it's not on if the first asymptote isn't at 0, then I would just go to the right and name that one first, pi over 4, and then they're going to be, whatever your period is, that many units apart. So it's going to be x cannot be pi over 4 plus pi over 2n. So pi over 4 is where the first positive one was that we had, and pi over 2 is what my period is. And my range is the gimme here. It's plus or minus from negative infinity to positive infinity. Okay, one more graph. Talk about this secant. And I changed it from 90 degrees to pi over 2. It's the same thing, y'all, but all of your homework problems are pi over 2. So I just decided to do that and label it. But you can obviously put it in degrees if that makes you happy. So to start off with, the number in front, again, is not the amplitude. It is just my A value, but it is the vertical stretch of my graph. Okay. My period is affected by the 1/2 in front of theta. And so it is 2 pi because, well, we should have talked about this first, but I didn't say it already. Secant is 1 over the cosine. The normal period for the cosine is 2 pi. 2 pi over 1/2 becomes 4 pi. So the period of this graph is 4 pi. Okay, and this pi over 2 is having a phase shift to the right pi over 2 units. Okay, so, and I didn't write how many tick marks, but I'll do that in a second. Okay, so my period is 4 pi. I go 1, 2, 3, 4 units to 4 pi. Halfway is 2 pi. Add them together to get the next one, and then you see the pattern. So the red ones are all multiples of 2 pi. Okay. I do not have any vertical shift up or down, and I know that key point has to go up to and down to, so I did not feel the need to relabel my y-axis. Okay, so it's 1 over cosine, which means I'm using those key points for the cosine, but I didn't write down how many tick marks pi over 2 is. So if this is 2 pi, then that means that halfway is pi, which means halfway again is pi over 2. So that means that according to my graph, you might want to think of it this way, is right pi over 2 is a half. That doesn't look like a half. Half of a tick mark. Okay, so when I put down my key points, okay, I start at cosine. Cosine starts at a max, and a max in this case would be at 2. So I would go up 2 on this black line, which is my y-axis, but I have to move it right half a tick mark, which puts it right there. Then I go 4 tick marks later and put the next one, because that's where it ends. And then halfway, so notice I went halfway here, so 1, 2, 3, 4 is halfway between those two lines. And then halfway between these two, I'm going down to my min, and that was kind of, I don't like that one. He's kind of really fat. Sorry, come back. All right, so halfway is there, and then halfway between each of those is my 0. So if I were graphing the cosine function, it would be like that, tall, because that's what the 2 does. Okay, and everywhere we have a 0, we have asymptotes, which is why those asymptotes are there. And then at the other key points, we draw parabolas away from our midline. Okay, so the domain, tricky part because we have asymptotes, so you can see that's why I labeled it. Go away. Go away. Asymptote is at 3 pi over 2, and the next one is at 7 pi over 2. So I am going to start with 3 pi over 2 because you want to start with that first positive one. And how far apart are those? I will tell you, with our tangent function, y'all up here, this number was equal to the period. But with these, we actually have it more often. We have 2 per period, so it's going to be 1/2 of your period, which is what you get if you subtract 7 pi over 2 and 3 pi over 2. So my domain is x not equal to, all real numbers, x not equal to 3 pi over 2 plus 2 pi n. And the domain, the range, I did use absolute value, but I know sometimes this can trip people up if the midline's not at 0. So you might be better off saying y is greater than or equal to 2 or less than or equal to -2. Or if you want to use your interval notation, then you can do that as well. Any of those is acceptable. Okay, write an equation for each function. Oh my goodness, I forgot to turn that off before I started video, and I'm almost done, so I'm not going to stop. Okay, write a cosine function with a being negative, less than 0, amplitude of 5, so that's my a value, and a period of 0.7 pi. Okay, well that period tells me that 0.7 pi is equal to 2 pi over b, because that's the parent function. So when I solve that, I get b is equal to, my pi's cancel out, or divide both sides by pi. And when I simplify that, I get b equals 8/3. It is a cosine function. So a goes in front. It is negative, and a was 5. So -5 cosine of 8/3 x. 23 says a sine function with a positive amplitude of 1.5. So a is 1.5. I should write that on here. This is my a value. Okay. And the next one we have, this is my a value. I think I forgot to write that down. Okay. So a period of 6 pi. So I'm going to say 6 pi equals 2 pi over b. And the pi, again, you can divide both sides by pi and simplify that and find out that b is 1/3. So y equals a times the sine of 1/3 x is the same thing as x over 3. Okay. These next two, those were just changes with a and b. These are going to be changes with your h and k. So if I have a sine function and it's shifted to the right, then that means that is going to be inside. So, and I'm going to the right, so that I know it's going to be minus. So it's y equals sine quantity x minus pi. I got a cosine function shifted 10 units down. If it's down, that means it's outside. And so there are no parentheses needed. Y equals cosine x minus 10. And then this last one, we have both of them. 4 units to the left is going to be inside, and pi over 4 units up is going to be outside. Inside parentheses, outside parentheses. Now, pay attention to this, y'all. Y equals sine of 2 parentheses x plus 4 plus pi over 2. So that 2 stays on the outside, because if you put it on the inside and just left that as 4, then 4 wouldn't be your phase shift. You only know that 4 is the phase shift if inside those parentheses that x is 1. So that's the only tricky part on the last problem for you. All right. Hope that was good. And please don't hesitate to email me or set up a Google Meet if you have any questions. Thank you so much, and y'all have a great day.